In part 1 of this rocket stove build guide, I talked about the heat transfer efficiency and why a rocket stove is great for off-grid use. In this video, let's design and build a simple rocket stove. Let's go off-grid. The first design for the rocket stove looked like this. It had a 14-inch flue and an 11-inch firebox. With this rough design for a rocket stove complete, I then prototyped it out of cardboard and had something that looked like this. It didn't stand up, was too short, and only had one air intake, which can't provide enough air for the fire. After a little bit of design work, I came up with this new design. Let me take you through the simple design so that you can create your own. The parts for a rocket stove consist of a firebox, flue, air intake, cooking surface, legs, handle, and a door. Let's start off with the two main parts, the firebox and the flue. For this, I will use 6-inch square tubing, with the flue being 18 inches tall and the firebox being 14. The firebox needs to sit 40 degrees up from the ground, so to achieve this, I cut the firebox 40 degrees inward. In order for the rocket stove to work, I needed to cut a 7.5-inch by 6-inch hole at the bottom of the flue. Let's move on to the air intake. Most rocket stoves have a large gap at the bottom of the firebox. The big problem with this is that after a lot of use, ash will build up at the bottom of the flue, which will block the air intake. For my rocket stove, I decided to have two air intakes, one at the bottom and one at the top. With this setup, when ash builds up at the bottom, there will still be a constant airflow. At this point, the bottom of the rocket stove is open. So to fix this, I got a 7x7-inch piece of steel plate for the bottom. With the basics of the rocket stove figured out, I began designing the smaller things, such as the handle. For the door, I found the steel cover with a handle that fit right over the firebox. I then drilled 2 holes for the hinge and 2 holes for the air intake. For the handle, I used a 10-inch piece of 3/4-inch square tubing that I cut 2 2-inch pieces at a 45-degree angle and a 6-inch piece for the top. The legs are made out of 1/8 by 1-inch flat bar that I bent at a 90-degree angle halfway up the 4-inch piece. For the cooking surface, I cut 2 12-inch pieces of flat bar, which I bent at a 45-degree angle halfway up the pieces. After they were bent, I welded the 2 pieces together at the middle to create an X shape, which will go on top of the flue. Now that I have a design for my rocket stove, I can now calculate how much metal I will need for the stove. I need 2 pieces of 6-inch tubing, one at 19 inches and the other at 14 inches. 19 plus 14 equals 33 divided by 12, and we get 2.75 feet for the 6-inch tubing. I need 2 14-inch pieces of 1.5-inch square tubing, which is 28 inches, or 2.3 feet for the 1.5-inch tubing. As for the 3/4-inch pieces, I already had laying around. And now that I have a design and metal, I can begin cutting and welding the stove together. Once I finished most of the welding for the stove, I noticed that it wasn't very stable when pushed from the firebox. To fix this, I cut a 10-inch piece of 3/4-inch tubing at a 40-degree angle that I welded to the bottom of the firebox. Now that I finished all the welding for the stove, it was time to paint the stove. Designs for the stove are available in the video description if you want to build your own stove. In the next video, we will test the rocket stove for cooking purposes.